Hi everyone, welcome to the MathSpellBook live stream. I'm your host Peter, and we're going to get into some proofs concerning functions today. So basically over the week I was doing some proofs involving like unions along with intersections, and I think I kind of understood a little bit of how those proofs work. But maybe I'll just try to do some practice problems concerning those. So let's see if we can find some problems here for those, and then we can move on to doing functions. So I want to do proofs involving them though. I don't want to do like because this one they already give you a set already to work with. Venn diagrams, draw a Venn diagram. Let's see. Usually the De Morgan, is it De Morgan? I always forget the name. Logic. I thought they would have like some problems I can do with like unions of sets and intersection and intersections, like you know how they work together. But maybe maybe not. So I did do these problems in the morning, at least the odd number ones, and I did look up some of the solutions for the even number ones, and I'm kind of understanding where this section is going with it. I think the one thing that surprised me was this one, because I didn't realize that this was when it has a symbol like this, I didn't know what that 5 was for, and I was like, oh, maybe it's like positive integers from 1 to 5, and then it turns out that's what it was in the solution. Okay, so I know we have some definitions here, so I think we should take this definition, because that way we can keep it. I don't know why it keeps layering up like that. Oh well. Let's see, so we have injective and unjective. I think this chart is a lot more efficient to have. That way I can have a better idea. Like, I already have an idea of what these are about, but at the same time, do I have a full understanding of them yet? Not really. So that's why I'm just taking all these. Okay, so we have the contrapositive and the direct approach. Now, from what I've read of this part, it says that the contrapositive method of proofwriting is more effective for injective. Because according to the actual definition, is that for all A and A prime in A, A is not equal to A prime implies that f of A is not equal to f of A prime. Because it's supposed to be 1 to 1, so let's see the examples here. So this is injective and surjective, so okay, so each one has one here. So it's not injective when we have this type of setup. And let's like imagine that the A axis is the set A is the x-axis and the set B is the y-axis. Okay, so it's not injective in this scenario, and it's not surjective here, because surjective means that it's onto. So for every element B, there is an A. Okay. So this one is not subjective because it has 2 and this one has 3, which means one variable might not get used in the B section or in the y-axis. Because this one looks like every one, it's equal on both sides. So there's equal amount of B's as equal amount of A's. This one is not injective because maybe it's because there's not enough B's to go around for every A here. And this one is not this one's not surjective. And it's not injective. So it's injective here. So we have, so the one part, if it's injective, is fulfilled, but I think because it's doesn't have an equal amount, it's equal amount, and plus it's not all of them are not linked up to each other. I think that's why. I'm just basically phrasing out my thoughts just to get a better idea of how to see the difference between the two. Because I think for injective, that I'm guessing like every element in A that is not equal to A has to be a different value. Hence probably the hence the like what do you call it, the vertical line test. Because we have 2 go to 4, so it's not subjective because there's no arrow to 6. So that's what I think why it's not subjective. So why is it not injective? So I guess it's not injective because we have 1 and 3. They're both equal to 5. I mean, they're 2 different values, but they go to the same value. Meaning that if it was F1 and F3, for some reason they're equal to each other. Pretty interesting, like. So I think we can highlight this too, actually. Well, not highlight, but take a photo of that. And then paste it right here. Cut that one out. So that way we have a structure of what we need to do for the proof. And I think we'll do the one for surjective as well. Didn't look nice. That's the reason why I didn't copy that at first. So let's paste here. Here we go. So now we have like what structures we should go for. I think with proofwriting it's kind of hard for people because like sometimes they're not given like I guess the way the structure should look. I think what I like about this book, I actually have a physical copy of this book and it's pretty worn out because I've opened it so many times. The second line involves proving the existence of A, which is B. Okay, so let's just read these little, because it's just a paragraph. I don't think it's going to be okay. So of these two approaches, the counterpositive is often the easiest to use, especially if f is defined by an algebraic formula. This is because the contrapositive approach starts with an equation f of a is equal to f of a prime and proceeds to the equation f of a equals a is equal to f of f a is equal to a prime. Got a little tongue-tied there. In algebra, as you know, it is usually easier to work with equations than inequalities. To prove that the function is not injective, you must disprove the statement a is not equal to a prime, implying that f of a is not equal to f of a prime. For this, it is suffice to find an example of two elements, a and a prime, which are in A, for which a is not equal to a prime, and f of a is equal to f of a prime. Okay, so that's why it says contrapositive. Yeah, that kind of makes sense, because contrapositive, you show that not Q is equal to not P, if you're thinking about it in logical statements. Next we examine how to prove that f a to b is surjective. According to the definition, I'm guessing the definition of this, yeah. We must prove the statement that for all b and b, there exists an a and a, f of a is equal to b. In words, we must show that any b in b, there is at least one a in a which may depend on b, having the property that f of a is equal to b. Okay, so suppose b is in b. Prove there exists an a for which f of a is equal to b. Okay, the second line involves proving the existence of a for which f of a is equal to b. For this, just find an example such as a would suffice. How to find such an example depends on how f is defined. If f is a given formula, you may be able to find a by solving the formula f of a equals b for a. Sometimes you can find a by just plain common sense. To show f is not surjective, we must prove the negation all of b is in b, there exists an a in a, f of a is equal to b. That is, we must prove that there exists a b in b, all of a and a, f of a is not equal to b. Okay, to show that it's not subjective. Okay, so the following example illustrates the ideas. For the first example, note that the set of real numbers minus the set 0 is the real numbers with the number 0 removed. Okay. So show that the function, the real numbers minus the set of 0 is equal to, leads to the real numbers, defined as the function. Okay, so we don't have 0 because x can't be equal to 0. It's injective but not surjective. Okay. We use the counterpositive approach, and suppose a is an a. So okay, we have a equals now subtract 1 from both sides and okay. Therefore, f is injective. The function is not surjective because there exists an element b1 this, if you minus this, then it'll lead this to 0, and then you will have 1 over x equals to 0, which will lead to a contradiction, because if you try to solve for x, you end up like you'll end up with like 0, like either, like if you try to solve for x, you end up like with 1 over 0, which is not allowed, or you basically get 1 equals 0, which is also not allowed, which is a contradiction, actually, I should say. Show that the function f of implies that it's f of 1, okay, where is injective and surjective, hence bijective, okay. The codomain has been changed at the previous example. To show that the subjective is into surjective, P is an element 6 and names, which is okay. So then we're left with this, and B is not equal to 1. Okay. In summary, we have surjective. Okay. The previous example shows that f of a is injective. Okay, so that's why they didn't write anything else here. Okay. So this shows us that the function g from the integer, the cross product of the integers with the integers, define the formula is both injective and surjective. Okay, so they use counterpositive, show that it is injective. Applies then, so. Okay. Then we got the function. And I remember reading this, so basically what they did is that they took this equivalent relationship and then layered it right here. So it's sort of like systems of equations, or systems of linear equations, I should say. And they just layered them up, so you basically try to take away the matching terms, and then you're left with, you know, and I had to read this like twice to actually like see what they were doing. And then next subtract. Okay. To see that the surjective is consider the arbitrary elements, and we need to show that equal to. Please note that means it leads here. Okay. Yeah, it's like a system of linear equations here. Now we have, and it follows that it's surjective. So let me just look at the definition of surjective again. So for every there's one more section to read. Okay, consider the function h, the Cartesian product of integers leading to the rational numbers. So we have a function here. Determine whether this is injective and whether it is surjective. This function is not injective because of the unequal elements 1 and 2, and 1, -2. So let's see. So if this would be 1 and this would be 2. Oh, okay, because this is the absolute value. That's why. So it's not injective because they both have the same answer here. However, H is surjective. Take any element of B, so BC. Oh yeah, here we go. So it's surjective. Take any element. So BC sum. So notice that we resume. We may assume that D is negative by making C negative. Okay. H and D is interesting. Okay, now we have these to work with. There we go. I was like, why wasn't my thing allowing me to copy stuff? Okay. All right, now let's do some problems. So let A be the set 1, 2, 3, 4. B, give an example of a function that is neither injective nor subjective. Okay, so give an example of a function that is neither injective or surjective. So how do we commence to do that? So we have A that is 1, 2, 3, 4, and B is equal to A. So it says give an example of that is neither injective or surjective. So we have to give a function that is not that. So it has to be a function, but it can't be injective or surjective. So let's look at the definitions of what those are. So for something to be injective, it has to be 1-to-1, so that we have A prime, A and A prime that are in A, and A is not equal to A prime. It implies that f of A is not equal to f of A prime. Hey Titan. It's good to see you on the YouTube live chat. What's the best part of your day so far? And happy Monday. So, for it to be injective, A has to equal A prime, and A of A prime has to be equal to A of A prime, F of A prime. And for it to be not surjective, so for every, there has to exist a B in B for all A. in A that f of A is not equal to B. Okay, so do we have to do this in a proof method, or do we have to do this like thinking about, I guess like sort of like spitballing? That's the one thing that I'm trying to figure out here. There's nothing good about Monday particularly. Well, I mean, at least you're up. That's one good part of your day. And you're here with us. so that's one part that's good about the day. Because I always ask everyone that question. It's like, what's the best part of your day so far? Some people forget that, like, oh, I got up this morning. It's like, yeah, you're up and about. Okay. All right. So give an example of a function. So it has to be a function, but it just can't be like injective or surjective. So I mean, I could draw a diagram, but I don't think that's what they're aiming for with this question. Hey, and Stunky. And I'll give you a shout out on my Twitch chat. If you guys are not familiar with Stunky, he is also another awesome math streamer. So shout out. And Stunky. But what's the best part of your day so far, and Stunky? I'm just popping in here before a shower. I'll catch you soon. Okay, no problem. If you guys are like in the Twitch chat, I put a link to Stunky's Twitch channel if you want to follow him. Check out what he's on the daily for like math. Well, it just started, and I did a review-a-thon schedule sent out. Oh, okay. Wow, that I maybe am actually organizing something for once. Oh, okay. Yeah, I think I got your message on Discord. And thank you for like actually considering me actually for that. Because I know like a majority of you guys that watch me, like some of you guys are already in undergrad, and you guys are like already like steps ahead of me when it comes to like math content and mathematical knowledge. So I'm like, to get that message from you, I was like, oh, interesting. I still have to reread it to get the details. Because I read it a little bit and I was like trying to understand exactly what it was. So but I do appreciate like you sending the message out, because it's like, oh my gosh. Because I felt like we haven't interact a lot, that's why. But yeah, enjoy your day, and Stunky. Okay, so thanks a lot, and Stunky. Appreciate that. Positive vibes to you. Positive vibes to you, my friend. Okay, so now give an example that is neither injective or bijective. Now I gotta figure out how to actually answer this question. Because I don't know how to answer. I don't know if we should answer it in sentence, because it doesn't say put a diagram, so I don't think we need to use a diagram. It says give an example. So the thing is that how do I write this in sentences? That's the real thing I have to think about. Because we know for it to be not injective, actually I should write that. Not injective and not surjective. We need to fulfill these requirements here. I mean, if you do this as a diagram, you have 1, 2, 3, 4, and then you have A, B, and C. Well, if we look at our examples in the graph that we saw, it's not injective and surjective. So technically one of these would have to match, so match with one of these over here. So if you have like 1 equals B and 3 equals B, then that would be like not injective because they're both the same output here. Well, actually, I forgot to put set A and B. And it would be not surjective if we left one of the letters out. So I think the example they left out C, so let's just leave out. So in this case, if we did this, and I guess we'll double up here. So let's see. So this is not injective, surjective. So I think the way they probably want us to do it is maybe like cassette notation, where it's like if we have F that goes from A to B, the function would be, let's say A 1 is equal to B, and then we get 3 equals to B, then we have 2C and 4C, and I think for good measure we can also do the other thing, the other functions. So that's probably one function we can go with, but we can also go with another one where it's like we can go with another type of approach where, let's say we took out C instead. So let's say A is equal to, and then 3 is equal to A, and then we can leave these the same. I mean, we took out, like, well, in this scenario, I guess we took out B instead. I mean, that's an example of it. I mean, actually, when I think about it, there's probably a lot of examples you can take. Because then when you think about it, this is like 2 to the power of 4. So if you do the math on that, because the 2 to the power, like, then that would be 16. So there's 16 different varieties of functions you can take from that. But I think all of them would not be, let me see. Because you have 2 choices out of 4 categories. Now, when I think about it, I'm trying to think about whether those 16 functions that we have in here, would those 16 functions actually not be surjective or and injective? Because I mean, that's a lot when I think about it. But then again, you could also mix and match, so it doesn't have to be 1 and 3, it could be like 1 and 2. So I'm guessing maybe out of those 16 functions, they probably won't be injective and they probably won't be surjective. That's the way I can break it down, and I think that's how we can get examples for those. So I'm wondering how they answered it here. So this is 12.2, so we're gonna have to look for 12.2. This will take a while because there's no section by section part in the solutions part, so I have to actually do this by hand. Hey Romaine, what's the best part of your day so far, my friend? This is exercise 9. I mean chapter 9's exercises, so we're getting close. This is 11, 11.2, 11.3. Here we go, 12. Okay, here we go. Oh yeah, we could have also done this one. It's also not. So I guess we got the layering of the argument, right? Like the way we're supposed to argue about it. I was going to like write out all the functions, but I'm like, no, because like when I think about it, like doing all that would probably like be, because like I kind of figured, like it was kind of funny, because like when I was reading about functions, I realized that the amount of choices here, because there was a question that basically was like, if you have two inputs and 2 outputs, they would result in 4 functions. Whilst if you had 2 inputs but 3 outputs. Oh no, if you have 2 outputs and 3 inputs, you would get 8. And then I was like, is there a pattern here? Because it seems like there's a pattern, and then I thought about it and I was like, wait, there might be a pattern here. And that's how I came up with this, because like the amount of choices you get is the base, whilst the exponent is basically the amount of choices you have in the input. Which I thought, like, I don't know if that is the way to kind of think about it, but when I saw that pattern, I was like, interesting. That is a very interesting way to think about it. So I wouldn't say we got the problem right, but I think we got the way to think about the reasoning behind it. Because I think the reasoning is pretty sound. Okay, so let's do number 2. Number 2, we won't be able to think of this. We won't be able to find the solution because I don't think they don't have the the even number problems. But we'll see how we can work it out. So I don't know why it keeps like doing that, like giving double versions. Okay, consider the logarithm function. The natural log such that 0 to infinity to the real numbers. Decide whether this function is injective and whether it's surjective. Okay. So the natural log of 0, I don't think that exists. Take a look. Yeah, it doesn't exist. So I mean, it's not in closed set parentheses. I mean, it's in brackets, but it's not like in closed set brackets, so I don't think it's including 0, but at the same time it's also in there. So decide whether this function is injective or surjective. So do we actually have to form proof with this? I'm just going to put Quizlet up because even though the additions are different, it might help us if we have like, I guess like a little guide. So let me just open this up. Okay, let me just drag this down here. So just in case if we need it, we can use it. Okay. Alright. So we have to deal with the natural log such that applies the real numbers. There we go. Decide whether this function is injective or surjective. Okay, so we're dealing with an infinite one, so we can't make a diagram like we did last time. So now we have to actually figure out how to start this. Because I mean, I think it's the same as like we did here. So technically this is a function that basically starts out with I think it's like all the numbers from 0 to positive infinity, and it goes to the real numbers, which is kind of, I wouldn't say it's the same, but at the same time, like, you know, we still don't, like, so the natural log is the function, so we can say that. So break it down. So this is the function part. This is probably the domain, and this is the codomain. So at least we'll get that down. Now, so for it to be injective, let's just start out there. So injective, we need it to be that we have A and A prime are in A, which is in the domain, and then A is not equal to A prime, thus f of A is not equal to f of A prime. And for it to be surjective, we have to know that for all of B, there exists an A in A such that f of A is equal to B. Okay. So I think we might have to actually prove something. So we're probably going to have to do these approaches. So let's see. We'll just write proof just to show that we're kind of starting something. So suppose we got A and A prime are in A, and log of A prime is equal to log of A is, natural log of A is equal to natural log of A prime. Okay, and I think the way we have to solve for A, right? This is because the contrapositive proceeds to the equation A equals A. In algebra, we know this. To prove we must disprove the statement. suffice that the two examples. Okay, so now so we have to show that so I think we have to solve for the variables, which is like a and a prime. So in order for us to do this, we have to actually do which leaves us with a and a prime. Actually, we forgot to write something. Same approach holds true when we solve for a prime. Therefore, a is equal to a prime. Okay, so that proves that it's in. Injective. Okay, so now we gotta prove that it's surjective, and based on what we saw in the example, show that the function is surjective. Suppose B, and then prove there exists A in A, which f of A is equal to B. So the second line involves proving the existence of an A, which f of A is equal to B. For this, just finding an example such as A would suffice. How to find such an example depends on how f is defined. If f is given as a formula, you may be able to find A by solving the equation f of A equals B for A. Sometimes you can find A by plain common sense. To show f is non-surjective, we must prove the negation of all B in B. There exists an A in A, or f of B. Okay. guess this is more direct proof method. So, all right. So, the way they wrote at the beginning of this one, suppose B. Okay. Put a little period here because we need to write complete sentences here. Suppose B is in B. I think that's what we write for the first part, right? Yeah. Okay, suppose B is in B. So, hoping when we solve for A, so in order to get A, we have to do this, which is also lead to this, and then we're left with A is equal to there exists A and A for which f of A is equal to B. Okay, so when we solve for A, we get thus when we wrote that in reverse. Thus when we substitute A equals B into the function natural log, equal to this, we would get wait a minute. Oops. I think I rewrote that. So it has to be B at the end. Oops. It has to be B here. That's why I was getting a little confused. Okay. So that's when we substitute A equals EB, e to the B power into the function natural log, we end up with, oops. We have to move this out first. Laws of powers, and this would be equal to 1. So thus, therefore, and natural log from 0 to is surjective. Okay, I think I might have made it a little bit too wordy though, but I feel like that approach is what we needed to do. But suppose that A and A prime. So we did prove that they're equal to each other, which kind of shows that they're injective. I probably should write. Now suppose that there's B. When we solve for A, thus when we substitute A and B, I mean, I think we did this right. I mean, I feel like we kind of did it right, but at the same time, it's like, probably use ChatGPT to see if we, because since we can't access the answer directly from a source, or maybe let me see Quizlet. Maybe let's see. I don't know if it has the same questions, but let's see number 2. So let's check it out. So the natural log. Okay, so let's see what they have here. Okay, let's show that is injective by contrapositive approach. Okay, we have from 0 to okay. From the definition we have I mean, they use like let's see, they used maybe, yeah, I thought, yeah, mine is a bit wordy. Let's take that they used was I think I just basically tried to take what I have here because I tried to do it the way they did in the book. It's like A and A prime is in A, and made this equal here, so when we solve for like A ends up like this, and we solve for A prime, it comes out to be the same. question is this the correct way to actually interpret it, or did I just wrote it wrong? Because I think with proofwriting it's really hard because you have to write it in a certain way where it's like it makes sense. And for me it makes sense in my head, but I don't know if it will make sense to any of you guys as like the readers. That's the thing about proofwriting that gets a little bit difficult, because it's like you know that when you write it out it makes sense to you, but if someone else picks it up and read it, then it might not make sense to them. And that's the thing that really kind of it can really throw you off. And I think that's why proofwriting is so hard, because you have to write with like an audience in mind. And when I see like an answer like this, I feel as if, wow, I didn't simplify enough, or I didn't write it clearly enough, and probably that might be it. So the way they wrote it was like, let's take x and y as an element of such that they're equal to z, and by definition, then x and y would be equal to, okay. I'm guessing the z is supposed to be like any type of construct or any element. I think what we did for B was I'm gonna try to see if I can. Oh, that's way too small. I don't know if ChatGPT will be able to read all this because it's so tiny. But let's see if we can get a response from it. It'll probably take a while to process it. Hey Sascha. What's the best part of your day so far, my friend? Yeah, we're doing some function proofs. Although I feel like this proof I probably didn't write it very clearly. Okay, according to ChatGPT, I mean, it says nice work, I guess. Like, at least it's like giving me a compliment on my proof. I can't do this often because there's a limited amount of pictures you can upload with ChatGPT. And I'm not paying for like ChatGPT Pro. Hence by ChatGPT. Okay, a few small points to tighten up. Submitting bloody functional analysis at 3 in the morning. Oh dang, 3 a.m. Sheesh. They must have been tough problems. Let's see, alternative remark you use the next time is strictly increases, so it's injective. Also correct. So the inverse function, thus every real number hits. Minor wording, you wrote that the natural log of e to the b power is equal to b, and you can add since e to the b power is greater than 0, and in the natural log is the inverse of x, that makes it the justification explicit. Wow, 104 pages of pain. Dang. PhD program is no joke. Yeah, and Stunky, I'm pretty sure Sasha needed that. Congratulations. That's what we call real rigor, right? Let's see, stylistic minor fixes. Keep notation consistent. Use A and A prime or A and B. Do not reuse B both as a codomain element as a variable. So state the conclusion at the end. Therefore, oh, natural log is bijective. Okay. You can tidy up some redundant steps in the search activity section. You solved for A and then substitute back, simply defining. Okay, I didn't like see stuff like that. I don't know if it's redundant or it helps prove the thing. Because like I think it's talking about this. Because for me, I just felt like I needed to do that because it's like, oh, I'm not just writing that A equals E to the B power, but maybe it is redundant to do it because it's like, oh, any mathematician could probably just read that and just put it in themselves. So let's see. Honestly, I only have one problematic instruction. The rest was pretty reasonable. Oh, that's good. So I guess this is considered redundant. I mean, I did it because I felt like, oh, I want to show what I know, but at the same time, maybe it is redundant. That's the thing that I kind of worry about when writing proofs, is that I want to show that it's all clear, but at the same time, it's like, which parts are considered more explanation and which parts are considered just things that are just straightly obvious that you don't need to put it in there. I'd say the second block is the operative one, and the first block you don't need. Which one? What are we talking about? This part? And this part? Is that what you're talking about in Stunky? Because I mean, actually, for all those that are like already doing math research or undergrad in math that have experience with proofwriting, is it very stringent on what you write when it comes to proofwriting? Because for me, I feel like this is how I do proofwriting, because it's like it makes things very, very clear, at least for someone that probably is learning math on their own, for me. But at the same time, it's like, I guess it's not up to professional mathematician standards. So, you know, like I know, like with math proofs, it leaves it out on purpose because obviously it's for mathematicians, and it's for them to actually see it for themselves and write it out for themselves. Not really like, you know, it's not like it's not like it's all out there for them to see. Like for them, they actually have to look at it and think about it a little bit. In principle, F is surjective proof. Looks like this: for any B, define A equals something, then calculate that f of A is in fact B. So you're saying that this is the important part and this was just the redundant part, right? Is that what you were saying, and Stunky? Because you said first block and second block, so I'm guessing the first block is this one and this is the second block. Is that correct? Oh, we had an ad break. Yeah, I'll reinstate my question. So and Stucky, you were basically saying that this part, I guess you're thinking that this is the first block, and you're saying that this is redundant. while this is the second block, and you're saying that this is what exactly the proof needs. If this were an intro course, I'd make a comment about it, and probably take at most 1 over 10 off. It's very good A-level work, if not perfectly. Oh, okay, so I was right in my assessment of what you were saying. Okay, that's good. Well, I don't think it would be A+ material, because like I noticed with proofs, like I'm not a very good writer. And it's funny because I was an English major. Like I wrote like B style papers, and they were not really great writing. It was funny because I actually had a job at a tutoring center to tutor students how to write essays. And like when I wrote my own essays and submitted it to like the TAs of my English courses, they would be like, "We recommend that you go to the tutoring center." And it was funny because I was actually ironically tutoring people to write essays for like their essay writing courses, and I find it very funny. Yeah, I wasn't really good as an English major. I picked it because I really liked the literature. Well, I didn't like literature. I liked writing, but then I realized that when you're an English major, you just analyze literature, and I was like, I didn't read any of the material. I would just pick out quotes, and funnily enough, I got lucky because there were times when I picked quotes and they had nothing to do with each other, and then in my brain I thought of like a deep connection with them, and I would think about the story that they were about, and then I would be like, wait, I can make this quote and this quote work together in some way, even though it was kind of abstract and everything. But whenever I wrote it on paper, it was the TAs and probably the professors didn't understand what I was talking about. But they still gave me B's, so I'm like, I must have done something right. If school wasn't so expensive and I didn't have to pay for like school, if it wasn't a hefty price to pay, I probably would have changed my major to mathematics if I knew I was going to enjoy this much. But at the same time, like for me, I feel like if I were to go back to school for math, I want to make sure that I don't have any distractions. So in other words, like I don't want to be distracted by like a part-time job that I have to constantly go to maintain like balance in my account and all that stuff. So I guess we're gonna have to write this as the conclusion. Thus, the function. Oops. Because according to ChatGPT, that's the one thing that we're forgetting. To the real numbers is bijective. And then we'll just do the little... What do you mean that's a mood? Is it because like that's something that most people would like to do if they're like studying like academic pursuits like physics, mathematics, or biology or chemistry? No distractions. No distractions from like, I guess, life in general. Probably that's a good assessment, I think. Okay, I think we can do question 3. I think we're doing pretty well though, but I appreciate the compliment, Stunky. It actually makes me feel like I'm actually getting at least decent with proofwriting with that comment, actually. Because like when I was doing like De Morgan proofs, I couldn't fully understand the structure of how they were done, and I was like, I would write a lot of sentences, and then when I would show it to ChatGPT, it would be like, oh, this is kind of redundant, or this doesn't like the way you're explaining this, it sounds okay, but it lacks something, or it lacks clarity or something, and I'm like, oh, what do I need to do to actually like to write the proof correctly? You know. I mean, it's a common desire. It's certainly my desire. Certainly my desire, and why I keep dragging my feet on getting gainful employment. Yeah, true. Oh, okay. Yeah, Sasha always does his best to reassure me whenever I feel like I'm like going down, I guess, the typical what I call the typical math lover emo rabbit hole. The reason why I say that is because I'm pretty sure many people that love math or physics or any of the STEM subjects would probably feel like, I love this subject, but at the same time I feel like I'm not good at it. At the same time, I'm going down this spiral where it's like, am I even getting good at it at all? And you start having like this inner monologue in your head, and you have like an inner crisis where it's like you feel like your love for the subject isn't enough, and you're doing your best in it, and you're like, why is it that I am not doing this right? You know? But I think that's like every math student slash math enthusiast conundrums they deal with in that because it's like, you know, it's hard, but at the same time it's like, if you're willing to actually try to find the blockage or try to find what I guess like what is the correct approach, or what is it that the final answer is saying, then I think that's when you actually realize maybe I have to copy it a little bit, but at the same time try to understand it in my own way. Because like when you look at proofs and you see proofs like in the answer key, you feel as if, why didn't I write it like that? But probably in actuality what you should be asking yourself is, what is it about this proof that I can do to make it my own, but yet still reflect the same model that's in this answer? Because I think whenever I look at answers with proofs, it just feels as if like, wow, they wrote it so clearly, and I felt like I wrote nothing but paragraphs. And it just feels like it only makes sense to me, but it probably won't make sense to a reader that's reading my work for the first time. Okay, consider the function so we're dealing with a trig function from the real numbers to the real numbers. Decide whether this function is injective and whether it is surjective. What if it had been defined as cos? Oh, okay, so we're doing it twice. Okay. So we'll just write the thing we gotta do. Prove R to R is injective. Well, actually, we should write bijective. I don't know if it is, but I think that's what the question is asking. So, proof. Oh, I should leave it at 70%. I actually like the way it looks. It looks much more, it doesn't look as thick. that's. I think I like this way. I probably should give it at 70% instead of 100%. What I'm talking about is this the zoom. Okay, so in order for it to be injective, actually I should write supposed. Suppose A prime is in A, and cos of A is equal to cos of A prime. Okay, so period. When we solve for A, let's see, cosine of A prime. So at this point, it's been a while since I've done the inverse of cosine. I mean, for some reason I feel like it looks like a mess. There's a part of me that's like, should we do it like the way should we do it through ratios, where it's like we have like x and x prime, like x prime over y, no, x prime over like r prime or something like that. I mean, reading it out, but I think that's just probably breaking it down too much. This one's a bit shorter. It's a bit shorter than the last one, but whether it's good or not, let's see. What if it had been defined as one to one? So I think we have like two proofs to do. So it's like prove. Well, actually not prove, but like see how it turns out. So from 1 to -1. Oh, I think I forgot to write a prime there. What if it had been defined as so if B was -1 is -1 and 1 at that point, then we would have to conclude that the range would have to be from like 0 and or pi and 0. I wonder how they came up. I wonder how they wrote that part. So let's see solutions. This is number 3. So let's see how they wrote that one. Scrolling. I think this is 11, so 11.2, 12.2. Okay, here we go. Okay, consider the function. Okay, so it restates the question. Oh. It's not injective, so. Oh. Oh, we got that totally wrong. I guess I had to think of counterexamples for that. I guess like for me, it's like putting the knowledge of math that I have from like calculation-based math and putting it together with proof-based math. I think that's the thing that I've been kind of like, I realize that's what I've been cut off with, because it's like put the knowledge together and like remembering how they work from like what I learned from calculation-based math is like, that's the part that I haven't worked on that much. I think I was just so focused on the proof technique, like how to write the proof cleanly. So we had to prove that we have to show in our proof that it wasn't like that. example, 0, right, yeah, they give like examples like this, which is 0. It's not surjective because b equal to 5. For example, there's no real number, which oh, okay. Yeah, I didn't think about the proof breaking. I was just thinking about like how to write it out like this. But then again, like did I read the question wrong? Like, I think it's because like I was like, say like decide whether the function is injective or bijective, but I think like when I read that I was like, write the proof that suggests these things. And I guess that's where I kind of follied, because I was like, oh, I have to do this algebra and stuff. But when I think about it, like based on how it works on the calculation basis, I was like, wait, no, that doesn't make sense. Because it's between 1 and -1. And I'm like, wait, hold on. There's a reason why these functions are different. I mean, I'm trying to think about what I learned from this. Besides, like, you know, remember the mathematical behavior of a certain function. And because I thought, like, I think for me, whenever I think about proofs, I think that the proof is supposed to tell you exactly what the behavior of the what the math is doing. In other words, like, I thought that if I wrote a proof, there's something in the proof that should tell me that, hey, cosine is not bijective. But I guess, like, for me, I just put I guess I put too much emphasis on like cosine being part of the real numbers. You did not read the question wrong, but you got the wrong message, yeah. If you listen to the recording, you'll hear yourself say something like, oh, well, this probably means I need to prove these things. The wrong message, okay. So I guess like what would you guys suggest, like, how I balance that? Like, because obviously, if I were to think about the behavior of cosine, but it didn't came to me at first, because I was thinking like, oh, here's a proof question, I have to write a proof that says that either it's correct or wrong. But at the same time, I think maybe I put too much faith in that the proof would actually say, hey, it's wrong because of this thing, or it's not going to be injective or surjective because of this. But I wasn't thinking about that. I was actually thinking about how to write this as a proof, which in actuality is wrong. I mean, that's what you expect, I guess. Because I think for me, I just think that the proofs are the thing that's supposed to tell you that it doesn't behave that way, but at the same time, it's like, no, you still have to observe the behavior of it outside of the proof. I usually think of it as sort of like when you're doing calculations within electricity, you have to remember there's a positive charge and a negative charge, and you have to do certain mathematical I guess tweaking to basically make sure that it knows there's a negative charge instead of a positive charge within the math. So I'm taking that and I kind of comparing it to this, because it's like, I thought the proof would lead me to say that cosine from the real numbers to the real numbers is not bijective. But I ended up writing that it is bijective because I thought I had to prove that it was bijective using the method that I did before in this one, but which is not the case, because I forgot that cosine is really not bijective at all, because it's only going by two places within the output. It's surjective but not injective. Okay. So now I'm gonna break down why I got it wrong. So I think it's because the reason why I think it would be considered wrong for it to be bijective is because I wasn't paying attention to this part, because I wasn't thinking about numbers, the way it functions actually. And maybe that's the reason why I kind of like went off on this, I guess you could say, perfectionistic tangent here. Although it does feel, I do feel bad that it's like, oh my gosh, this is wasted. This is all wasted energy. I mean, the proof, for me, I felt like maybe I was going on the right track, but then I was proving the wrong idea. Yeah, the balance is an art for sure. It's always worth taking some time to see the objects improved in action. Here, that probably means draw a picture of the function. There's no great advice. No, I get that. I get that. It's like, I think it's because my brain is like, there's proof-based math and there's calculation-based math, and I forget that they're part of mathematics, so I don't merge them together, because it's like, with calculation-based math, I think, oh, that's only in the domain where I have to calculate numbers and actual values of something in the I guess like in the physical world. But when it's the proof-based stuff, I think of it as its own separate domain where it's like, there's no numbers, there's only variables, and I can only prove variables. I have no use for like the numbers, like in like the Arabic numbers in this case. But maybe that's the wrong thinking, I think. Like, I think of it as sort of like I'll draw a picture. I think of it like this, where it's like proof writing, where there's variables, ideas, but no numbers. Just sets. And then right here, I think of it calculation-based math. Like in here would be like techniques, numbers, and equations, but I don't merge them, and I think that's the reason why I kind of went like nowhere with this one. So I guess I have to find something that just like meets in the middle here, to make mathematics here. Or maths, I should write maths there. Okay, it's a good thing to observe, yeah. I think that's something you have to run into. So this one is a big no-no. Yeah, it sucks to actually have to put an X there, but, you know, I guess it had to be done. Alright, back to this. So what does 4 say? Okay, so we have another verifying thing, where it's like, take this. We have about like 15 minutes, so I don't know if we're gonna get this question done by that time, but we'll just give it a try. How many more weeks till next month? 2 more weeks. Well, technically 3, including this week. Well, then again, no, it's 2 weeks. It's 2 weeks until the next month. Because actually, I like October. October is like when Halloween vibes occur, when everyone can cosplay. Any of you guys plan to celebrate Halloween? I don't really celebrate it that much, but at the same time, like, I like a holiday where it's like you can just like dress up as any character you like from any show or any book or any series that you like, and then like you just like, it's sort of like you're not being an actor, but kind of embodying the characters that you like from like pop culture and fiction and all that stuff. Okay, the function from Z to, okay. So we're gonna go from one specific element to like a pair, an ordered pair. That's really interesting. Verify whether the function is injective or bijective. So I guess when it says verify, whether it be it's injective or bijective, I probably have to think about it first. So I have to think about how it behaves. So it's basically the integers. So I mean, if you do put any of the negative numbers in this function, I think it would give an integer. It doesn't seem like it would give things like the square root of 2 or pi or anything like that. Verify whether the function is injective or whether it's surjective. So, if we think about it this way, so let's say we have let's say we take little z in z, and then, well, actually they use n, right? Yeah, they use n. So let's say n is in the integers, and then we have n, f of n is 2n is 3n. So I mean, any number would fit, like any integer actually. So would there be two integers that would give the same result? That's one question, because if two integers give the same, I mean, if one n gives the same result for two outcome, if like two n's give the same outcome for this, then that means it's not injective. So let's see. I mean, you could pick number by number, but that would take a long time at that point. Because I don't think there's any number. Let's see here. Equals. And then if it doesn't turn out to be n equals 3, so that means that yeah, because then it will turn out to be 6 for n equals 3. But at the same time, does -3 give the same result? And I don't think it does, because because we have -3, that would be 0, and then -3 times 2, that was -6. So yeah, so I think it is injective. And verify whether this function is injective or whether it is subjective. Okay, so I mean, the way I think about it, it does seem like it is injective, but now we have to actually prove it. That's the thing. So proof. So now I'm actually thinking about the behavior of the thing. So it's like let A and A prime be an element. Well, actually, maybe we can use n at this case. So it's like let n and n be an element of real numbers. I mean the integers. Then f of n is equal to the ordered pair of 2n and n plus 3. Let me just just erase this because I feel like it's going to get in the way of the writing process. So, okay, now f of n is equal to f of n prime, so now we gotta actually like think about how this would work. Because now we're working with ordered pairs, not really equations, which probably makes this a little bit harder. Because algebraically it's like easier to work with equations than just like ordered pairs. But with ordered pairs, I think you're gonna have to mess with it a bit. Like probably make the whole thing 0, like one side 0, and then the ordered pair, like, you know, because thinking about it like this, where it's like 2n prime and n prime plus 3. The thing is that if you try to actually solve for one of them, you can't really do that because you end up with something like similar to this, where it's equal to 0, and then at this point you're going to be left with like 2n minus 2n prime, and then you're going to be left with n minus n prime. And I don't think that's what we should be aiming for at that point. But then again, those equations can like lead up to all of them equaling to 0. So if we have, but we can do this in a different way actually, maybe if I think about it differently here. Because I'm just thinking about the examples that we saw in the book. Because let's say if we had this plus and they're both equal to 0, so it's like prime. Maybe not. Part of me was thinking that I could do something clever. I think that might be a bit of a stretch. Let's see what we got here. Maybe looking over the examples again might help. Because here we have one where it's a pair, but then it goes to a rational number. But then we have a function here, so let's see if maybe this one can help us. Because usually with the symmetry in mathematics, usually what happens into the opposite might be the inverse we need to actually get an idea of how to solve it. Or at least get a clue as to what we're supposed to do. So in our case, we have a function that works as an ordered pair, so let's determine whether this is injective or bijective. This function is not injective because it's so we don't have any like absolute value signs, so I think that's going to be okay. However, it's injective by taking an element B and okay, so we know that the B in our case, that's going to be a pair because I do think that this is actually injective because every single number that we can put in here is the integers, and it doesn't seem like any of them would repeat each other. So I don't think we're going to get an output that repeats. At least that's what I believe. Like, based on the way I'm trying to imagine the behavior of this set graph here. So maybe we can draw a graph just to make sure. We'll just make it 3, -3, and +3 here. So if we have n equals 1, then that means well, actually we'll make it 6 so we can have more space. Okay, so if we have 1, that would be 2, and that'll be 4, so it would be 2, 4 up here. And if we had them at 0, so this is 0, this is 0, so it would be a 3 right here. Yeah, so it would be a linear graph, I think. So if we had -1, it would be -2, and then -1, yeah, so it would be -2 to 2. Yeah, so it's just gonna be a line that goes like this. So I think it is injective because based on the way this graph behaves, it's just a straight line at that point. Determine whether it is surjective. So if it's surjective, then that means it's gonna have like a result. So one thing is that to prove it's subjective, that's because I'm thinking of it as an equation, but at the same time it's like, how do you undo an ordered pair? That's the thing. Do you have to actually like do you have to treat each part of the pair as like its own separate equation, I guess? So I'm guessing like B would have to be equal to like n to n, and then B would also have to be equal to n plus 3. So did have that in that case. So if you have n is equal to being, and then meaning if you have, the problem is that n is equal to 2 values. That's I don't think that's allowed, but if you were to do that, times 2, and then for the other side, so I don't think it's going to be surjective. I think it's injective, but it's not surjective, because there's 2 ways you can actually have B with this. Let's see, because like I feel like the thinking of it, like I'm doing it like the way I didn't do this one, but at the same time, like I'm probably not writing it correctly, like the way they probably expect me to write it. So this one is number 4, right? Yeah, this is number 4. Let's see what they did for exercise 4. Hopefully it's the right one. Yeah, I kind of figured that it was going to be some sort of dynamic like this. It's not surjective, but for as for 0 is equal to 0. There is no x in such that the function x is equal to 0. Yeah, because it will never hit it. But now I just want to make sure that I understand this part, because I had a feeling it was not going to be subjective, because it's like, in order for it to be subjective, you have to make sure that n is equal to like something that would get these both to equal n, and apparently that's doesn't seem like that's going to happen based on how different these two are. If they were like the same function, then I mean the same equation, then probably that would give us some leeway, but I don't think that's going to work. So it's injective but not surjective. So my thinking was correct in that. I just didn't know. So I guess to do it by contrapositive or injective, I have to do it this way, where it's like I have to imagine that it's like x and y, and put that in, and then basically we can do it that way. So that's something to keep in mind. Okay, so I feel like I'm slowly learning a little bit. Like, does that mean I mastered the whole thing? No, but at the same time, I feel like I'm kind of getting a clue. So I'm probably, there's a lot more problems here, so maybe like during this week, we're gonna probably work through these problems involving functions. I don't know how far we'll get, but probably like during the rest of the week, I'll probably try to cover these topics too. And the best thing about the 3rd edition is that there's proofs in calculus. So I feel like once I have a good idea on how these work, like the function proofs, then I'll probably be kind of equipped to actually handle some stuff from real analysis, I think. But if anyone in chat wants to, like, you know, tell me that I'm getting ahead of myself, then please do. If anyone thinks that that's a good plan, please let me know. Because that's what I have in my brain so far. And I think that might be a good, like, either I'm just going to continue on with functions, and once I'm able to feel comfortable with them, then maybe I'll go back to equivalent relations and equivalence classes to, like, probably solidify my knowledge in those, and then hopefully like move on to like actually real analysis stuff. I think that's the plan, hopefully. Because I do study off stream too, so Hopefully this will all work out. If not, then I'll just like try to reroute and try to like fix it along the way. Okay guys, thanks for joining me today. Like if you like math, physics, or just need a study stream to keep yourself productive, if you're watching this on YouTube Live, please hit the sub button, in addition to like hit the like button, and put a comment down below if you're watching this after the live stream has like already been like after the live stream like probably is like already done, and like you're just watching this on the back end. But if you're watching this on Twitch, drop me a follow if you like math and physics and you want a study stream to keep yourself productive at your leisure, or like during your study time if you have to study for exams, because it is like the school semester I think has already started. So hopefully I can help you guys like get your productive muscles in gear for your upcoming like studies and exams. And thanks, and Stunky. I will put the link in the Discord in the chat for Twitch. In addition to my video game channel, we're actually going to do a podcast on my video game channel today, so I'm looking forward to that. So you guys can check that out. If you're watching this on YouTube Live, all the links will be in the description down below, so you can check those out at your own leisure. But thanks for joining me today, guys. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys tomorrow for the next math proof filled stream. So take care, guys. Bye-bye.